Hello, this video is a short introduction to the dot product. First, let us start by motivating the concept of a dot product. And one way to motivate this concept is to start with some notion known in physics, namely the concept of work. Suppose you are given a force F which is acting on an object which is located at P, and this force here is constantly pointing in some direction. Also, the magnitude of this force is constant throughout the entire motion, where this force is moving the object from P to Q. So PQ as a vector is called a displacement vector. Now, the work done by this force is simply obtained by looking at the projection of the force F onto the displacement vector. This force is actually obtained, this vector is obtained by PS, and to compute the work, we take the magnitude of PS times the magnitude of the displacement function, which is PQ. So all of this together is nothing but the magnitude of the force F time the magnitude of the displacement function PQ time cosine of theta, which is an angle in between the vector PR, the force F, and PQ. So this need to combine two vectors and get a number is the reason why we will look at the concept of dot product today. Let us start by some definition. Given two vectors with components u1, u2, u3, and v1, v2, v3, the dot product of u and v is defined as follows. You take u1 times v1 plus u2 times v2 plus u3 times v3. So it's a simple type of product, but has very useful implications. First, let us look at a very simple example. Let's consider the vector u and v with components u24 and 312 respectively. The dot product of u and v is simply obtained by taking u times 3 plus 2 times 1 plus 4 times 2, which is equal to 13. Now, the dot product has some very useful properties. The first one, the dot product is commutative. So u dot v is equal to v dot u. And the dot product distributes itself inside vector addition. So u dot v plus w is nothing but u dot v plus the number u dot w. And c as a real number time u dot v is c time u dot v. The vector 0 dot any vector u is equal to the scalar 0. Also, if you're given a vector u and you dot this vector by itself, that is actually equal to the square of the magnitude of the vector u. Let's check this last property. To verify this, all one needs to do is simply appeal to the definition. Take a vector u which has for components u1, u2, and u3. Well, by applying the definition of the dot product, u dot u is u1 square plus u2 square plus u3 square, which is exactly the square of the magnitude of the vector u. Now, this theorem here is probably one of the most important theorems which is related to the dot product. If theta is the smallest non-negative angle between two non-zero vectors u and v, then the dot product of u with v is actually equal to the magnitude of u times the magnitude of v times cosine of theta. Now let us pay attention to the conditions of this theorem. It is really important for theta to be the smallest non-negative angle in between two vectors. Notice that given two vectors, it's always possible to find two angles in between them, and depending on the orientation, the angle which is picked could be negative. However, in this theorem, the starting point is that we assume that theta is the smallest non-negative angle in between the two vectors. So a quick observation here is that two vectors are perpendicular to each other if and only if the dot product is equal to 0. And this is nothing but a corollary, a consequence of the previous theorem. You might want to stop this video for a few minutes and check this observation for yourself. Now, let us look at a specific example. Suppose we are given two vectors u and v, and we are interested in finding an angle in between the vectors. So suppose u has for component 1, 2, and 3, and v has for component 2, 1, and 1. We know that there is a relation between the dot product of these vectors, the magnitudes of the vectors, and the cosine of the angle in between the two vectors. So first, computing u dot v, we get 1 times 2 plus 2 times 1 plus 3 times 1. And this is equal to the magnitude of u, which is this here, which is this quantity here, times the magnitude of v, which is this quantity here, times the cosine of the angle in between them. Since we are interested in finding the angle in between the vectors, we will solve this equation for cosine of theta. So cosine of theta is equal to 1 times 2 plus 2 times 1 plus 3 times 1 over the product of the magnitudes of the two vectors. You might want to stop the video for a few minutes and double check that in fact this quantity is equal to square root of 3 times square root of 7 over 6. So since theta is the smallest non-negative angle in between the two vectors, then theta is obtained by taking arc cosine of square root of 3 times square root of 7 over 6. And by using a calculator, we approximate this to be equal to 0.70167 radian. Thank you.